Hello everyone, so in this video, we would now be solving for the influence line diagrams for statically determinate trusses. So in order for you to understand the concepts that will be taught in this video, you must first watch the previous video lectures that I have posted I should say, on influence line diagrams, specifically the introduction to ILD. So in today's lecture, we would now be determining the influence line diagram of member DJ. So this here is member DJ and solve for its bar force due to the given load. So after solving for the ILD or after graphing the influence line diagram, we would now be making use of that diagram in order for us to get the bar force of member DJ as given or as brought about by this actual loads. Okay, so let me just reiterate the definition of ILD from our previous videos. Again, when we say influence line diagram, this is basically a graph that represents how the location of the loads would affect the result. So in our previous computations, in our previous lectures, we have solved for there the ILD for beam reactions, the ILD for shear, and the ILD for moment. Okay, so right now, we would now be solving for the diagram for truss members. And when we say truss, theoretically speaking, that a truss by form of triangulation, because we have a triangular setup, we could say that the moment and shear are actually negligible. And from that, only axial forces are solved for here. Okay, again, that is theoretical. So again, the results that we would be discussing now are that of axial loads. Okay, so in this truss, this is now the specification. So we have six meter span. So we have 1, 2, 3, 4, 5, and 6. So we have 6 meter span each. So meaning that this is 6 meters, 6 meters, 6 meters, and etc. And we would now be having a truss with height of 5 meters as said here. Okay guys, so whenever we are to draw influence line diagrams, it would actually be better for us to disregard the actual loads first. So as you can see here, we have actual loads here. And if we are to draw the influence line diagram first, it would be better to get rid of them first in order for you not to get overwhelmed and not in order for you not to get confused. So with that guys, let us just remove that. Okay, so this is now the truss that we will be solving for. And let me just move it to this side. Actually, not move it, rather isolate the specification. So what we are to do is once again for us to introduce unit loads. So unit load. Then say that this is now the unit load. But take note guys that this is pin support or a hinge support. So meaning that it also has a horizontal support. So if that is the case, guys, what you would be doing. So let's suppose that this is now the unit load with the initial location, which is at the leftmost corner of the truss. So since we are particular with the member DJ, upon placing this load here, what we would be doing is for us to solve for the bar force of member DJ. So previously we had two methods, namely method of joints and method of sections. So if you would be solving for it via method of joints, it would actually be very time consuming, because since we are solving for this bar force, if you would be making use of method of joints, you would be solving for this joint here. Then after solving for this joint, you would be solving for this joint, this joint, this joint, and then this joint before you could reach the J. So in our video for today, or in our lecture for today, I will say that before watching this video, please master method of sections first in order for us to get an efficient scoring, or sorry, not scoring, an efficient solution for the flow. Okay, so for method of section, what we would be doing in order for us to get the value for member DJ is that we will be cutting a section at this part. So after cutting a section at this part, you could now solve for the value for dj. Then from that, guys, at this location, solve for the value of dj, and that is already your first coordinate for your ILD. Then after doing so, you would be moving the load from point to point up until you reach the final one. And just graph the result. Okay? So again, if this is the ILD, so let me just show you what the influence line diagram for member DJ would now look like, or would look like. So it would now look like this. So yan na po yung sagot. So dyan na po nagtatapos ang ating video. Bye-bye. Okay, so as for the solution, paano po ba natin nakuha to? So, same procedure as what we have been doing before. So let me just erase the answer or the spoiler. So again, let us get this particular value here. Then, ilalagay nyo lang siya sa mga points of interest up until you could graph the whole influence line diagram. Okay? So, let us solve for what would the result be for member DJ if the unit load is at the leftmost corner. So, since this is a pin support, we have horizontal and vertical reaction. So, let us first solve for the horizontal reaction. So, summation of forces horizontal is equal to 0 to the right positive. Basically, AH is equal to 0 because as you can see, or as you can see, we do not have here any presence of a horizontal load. Okay, so AH is now equal to 0. And in order for us to get the value of AV, let us get the moment about this point. So moment at B is equal to 0 clockwise positive. So that is now AV. So let us name this as value AV. So that is now AV times lever arm. So for the lever arm, that is the distance from this point up until this point. Okay. So for that distance, since we have here 6 meters for every span and we have 6 spans each, so that is basically 6 times 6 and that is 36. Okay. So 36 and then what else? Minus 1, this force here, times the lever arm of also 36. So this is now equal to 0. Okay? So solving for the value of AV, so I won't show in the calculator any longer. You could solve it by yourself. The value for AV is equal to 1. Okay? So AV is now equal to 1. So the only reason why we have solved for the value of AV is in order for us to solve for the value for DJ. Do we still need the value of DB? Actually, not really. So we do not really need the value of RB here unless you want to solve for it your own. You could do that. But once again, we do not really need the value of B in order for us to solve for DJ. Why? Because since we are to make use of the method of sections, in method of sections, we will be cutting a section at the truss. And after cutting the section in the truss, what happens with the bars that were cut? They will now be converted into forces. Okay, so as you can see here, this is now our cut section. So a while ago, this was our whole truss, but since we are to cut a section here, the right side will now be neglected. So kalimutan na po natin ang right side. And we will be choosing the left side. But take note that for the bar forces that were cut, they must be converted into forces. So in our assumption, it would be better if you are to assume tension. So again, this is just assumptions. And when we say tension, in Filipino, hinihila po siya. So it is actually stretching the joints. So if you have a joint here and we also have a joint here, as you can see by the arrowheads, that they are directed away from the nodes. Okay? So from that, let us now solve for the bar force DJ. But take note, guys, So for the bar force DJ, how could we solve for it? So there are plenty of ways to solve for bar forces. You could make use of summation moment, summation forces horizontal, or summation forces vertical. So if I am to choose summation forces horizontal, this is actually ill-advised in our scenario right now, because if we would be making use of summation forces horizontal, we have here DE plus IJ plus the horizontal of DJ. So DJ horizontal. As you can see here, we have three unknowns. Basically, we could not solve for anything here. So we will not be making use of this. But if we will be making use of summation of forces vertical. So since in our scenario here, the only vertical forces present is the vertical component of DJ, the value of 1, and then the value of AV. And since we have already solved for the value of AV earlier, we only have one unknown. Okay? So take note that this is not, this method is actually a case-by-case basis. In some cases, summation forces horizontal is more preferred. In some cases, summation moment is more preferred. And in some cases, just like in our case now, summation of forces is preferred. Again, in order for you to solve for the member DJ. Okay, but take note, guys, if we are to get the summation of forces vertical, we must first get the vertical component of DJ. So for the vertical component, let me just redraw this slope of DJ here on the right. So let us assume that this is member DJ. Okay? So according to our problem, the truss would have 6 meters dimension per span, and the height is 5 meters. Okay, so let us first solve for the hypotenuse here. So as per the hypotenuse, that is basically the square root of 5 squared plus 6 squared. Answer, that is now the square root of 61. Again, this is now square root of 61. Okay, so let us solve for the summation of forces vertical equal to 0, upwards positive, in order for us to get solve for the value for DJ. So 1 kilonewton, where did that come from? That is this one here. Again, guys, in our analysis, we are to consider everything here at the left. We will not consider the right side, only the left side after cutting the section. So again, we have this force here, which is acting upward, so that is positive, minus the 1 kilonewton load acting downwards, so minus 1 kilonewton. What else? So we also have DJ. And I have assumed earlier that it is tension, and by tension, in this case, it is actually going downwards. So as per my assumption, this must be negative DJ. But take note, guys, in this case, so in negative DJ here, this is actually incorrect, because we only need the vertical reaction or the vertical component of DJ and not DJ on its own. So via SOHCAHTOA, you could solve for the member DJ, or by ratio and proportion, you could do it this way. So DJ times the vertical component of the slope divided by the hypotenuse. Okay? So basically, DJ times 5 over square root of 61. So as a note, if you want to get the horizontal component, that is DJ times 6 over square root of 61. Again, this is the horizontal and this is the vertical. Okay? So let me just erase those. So again, that is now the value. So this is now equal to 0. Then solving for DJ, so looking at the calculator to your left, so this is now 1 minus 1 minus DJ if I am to make use of shift solve command. So times x times 5 over square root of 61. This is now equal to 0. Then shift solve. The answer is 0. Okay? So from that, guys, if the answer, or sorry, if the load is located at this point, the value for DJ is actually equal to 0. Okay? So with that, guys, if this is our truss, if this is our graph, if the load is located here at this point, sorry, the value for DJ is equal to 0. So from that, for the first point, we would now be um, assigning a certain point at this part. Okay? So next up, you could actually move this to the next node. Then after that, to the next node, up until once again you reach the last node. But rather as a shortcut, so since our the bar force is located here at this point, let us move this load to this joint here, which is aligned to this particular node at this point. Okay? So upon doing so, this is now the new location. And as you can see by our animation, since the value for the unit load would move, or the unit load would move to the right, the support reaction would also vary. It would now be reduced, as you can see at this part. And as you can see that AV is now unknown, and in order for you to know, then solve for it your own. Okay, so in order for us to solve, let us get the moment about B once again. Clockwise positive, so that is AV times 36. So again, the value for 36 is the distance from point B up until A. Then minus 1 kilonewton. And for its lever arm, for its distance, so once again, this is 6, 6, 6, and 6. Okay? So from this point up until this point, we have 4 sixes. So that is now 6 times 4. So, sorry. So 6 times 4, that is 24. So the lever arm here is 24 meters. So this is now equal to 0. Actually, that is equal to 0. Then solving for AV, transposing 1 times 24 to the other side. So that is 24 divided by 36. Our answer for AV is 2/3. Or, if you are to convert it into decimal, that is 0.6666667. Okay? So that is now the value for AV. And there, that is now our value. Then again, after solving for AV, let us now solve for the value of or the new value of DJ. Okay, so solving for the new value for DJ, again, let us get the summation of forces vertical, upwards positive. So that is 0.667. And then minus 1. So we have a 1 kilonewton load here acting downward. So that is minus 1. What else do we have here? So you also have the vertical the vertical component of DJ, I should say. So that is minus DJ. So why minus? Because as you can see in my assumption, that it is actually pointing downwards. So if it is pointing downwards, negative. Okay? So minus DJ times the ratio of the the vertical component of the slope divided by the hypotenuse. So again, this value here is just the DJ vertical. Okay? So this is now equal to 0. Then solving for the value of DJ, so looking at the calculator below me. So 0.667 minus 1 times square root of 61 divided by 5. So the answer here is, so let me just check. Oops, I forgot to group my answers, so this must be grouped first. Apologies. Okay, so equal sign. So the answer here is negative 0.52. Okay, so what does the negative value indicate? The negative value indicates that I have incorrectly assumed the direction. So since earlier, I have assumed it to be in tension, a negative value means that the true value for DJ should be compression. Thus, the arrowhead should be here and not here. Okay, regardless, so in our ILD, so for the ILD or for the influence line diagram, our sign convention is positive for tension and then negative for compression. Okay, again, if in order for us to solve for the ILD or for us to graph the ILD, if the load is located at this point here, what is the value of DJ? So earlier we have solved the value of DJ equal to negative 0.52. Thus, if the load is located here at this part, the value for DJ is negative 0.52. Thus, this is now negative 0.52. Okay? So again, for the lower part of the ILD, this is in terms of compression. And for the top part, this is in terms of tension. So, do you call this? The next thing that we will do is for us to move this load to the next joint or to this particular joint here. Okay? So, moving it here, let us now solve for the new AV. So, as you can see once again, if this was the previous AV, if we are to move this further, the value for AV would now vary and it would actually be lesser. So, after doing so, solve for the value of AV, cut a section here, then solve for the new value for DJ in order for us to solve or for in order for us to know the next coordinate of our graph. Okay, so again, summation of moment at B clockwise positive, that is AV times once again the lever arm is 36 minus 1, this is 1 guys, times the lever arm of 18. Where did 18 come from? So this is 6, 6, and 6. So the distance from this point to this point, that is 3 sixes. So 3 times 6, that is 18, thus 18. Okay? So this is now equal to 0. Solving for AV. So solving for AV, that is now equal to 18 divided by 36. That is 1 half. So 0.5. Okay, so AV is equal to 0.5. And from that, guys, again, AV is equal to 0.5 here. Then cut the section once again. Solve for the value for DJ. So summation forces vertical is equal to 0, upwards positive once again. And from that, that is 0.5. This is upwards minus DJ. Again, we only need the vertical component of DJ. So if you only need the vertical component of DJ, multiply the value of DJ by the ratio of 5 or the vertical component of our slope divided by the hypotenuse. So that is now equal to 0. Then from that, solving for the value of DJ, so that is now equal to 0.5 divided by 5 times square root of 61. So again, as for the algebra part, I just did it in my head. It would be up to you on how you would be solving for this. But my answer would now be equal to 0.781. So that is now positive 0.781. Okay, so from that, for our ILD, again, this was our first point. Then if the load or if our load is located at this point, the value for the bar force DJ would now be equal to whatever this value is, and that is 0.781. Okay, so that was, as you can see, the answer below me. Okay, so next, after doing that, we could now proceed to the last part. So if you want to know the values here, you could move this load to this joint, then to this joint, but I would rather move this load to the end already, since as by my experience, this would just vary linearly. Okay, so I would rather skip EJ, or skip the unit load and move it here already. Okay, because I know that the behavior would just be linear. So again, if you're having trust issues, then solve for the ILDs or the points at this, again, at these locations. Okay, so upon moving our unit load here, so as you can see that since it is already on top of reaction B or support B, reaction B would carry 100% of this load and leaving AV with no reaction. So from that, guys, AV is now equal to 0. Then if AV is equal to 0, if you would be cutting a section here, and you would now be getting the summation of forces vertical equal to 0, upwards positive dj times 5 over square root of 61. This is basically just equal to 0. Since AV is equal to 0, and since the unit load is on the right side of the truss or of our section, thus it is not, or it is neglected in our solution. So if you are wondering, so in this case, in our point, or when the unit load was located here, in the summation of forces vertical, it is included. But when it was moved towards this direction, so, or towards this joint, upon cutting the section, guys, as you can see that the unit load is not considered in the analysis any longer. Kasi nga, nakat na siya. We would not consider this part of the truss. Okay, so proceeding. This is now our ILD as I called a while ago. Okay, so let us now solve for the reaction due to the actual load given the ILD that we have solved. Okay, so what this influence diagram indicates is that if the load is located at this portion to the left, the bar force of DJ or bar DJ would experience a compressive stress or compressive force. If the load is somewhere here at the right side, so somewhere here from this point to the right, member DJ would now experience a positive force or a tensile force. Okay? So, as you can see here, guys, if the force is located exactly at this line, it would experience the highest compressive force. But if the load is located exactly at this point, the bar member would experience the highest tensile force. But as you can see here, it is actually the combination of right side and the left side. And from that, guys, we will be solving for its result or for its combined effects. Okay, so like in our previous videos, what we would be doing is just that we are to project it. Okay, so let us project this 40 kilonewton load downwards. Then from that, guys, you would be solving for the value for y1. However, guys, as you can see, since in this y1, that is basically negative 0.52. Okay, so no need for any solution since that is already the value for y1. Then for 50 kilonewton load here, for this 50 kilonewton load, if you are to project it downwards, so this is now its projection. And once again, for the value of y2, no need for solution because that is already 0.781. Okay, what about for the 50 kilonewton load? If you are to project it downwards, so basically we do not know what that value is. Okay, so with that, guys, let us solve for it. So let me just move the 0.781 force there, and let us solve for y3. So for the value for y3, guys, so let us just get the ratio and proportion. So as for this whole big triangle here, sorry, again, so as for this whole triangle here, the slope of this whole triangle, that is rise over run, so for the rise or for the vertical component, that is 0.781 divided by the run, and the run in this case, that is the distance from this point to this point. So as you can see here, we have 1, 2, 3 spans for this whole distance. And for 3 spans, so that is now 3 times 6. So that is 18 meters. So from that, guys, this is 18 meters. So this is now equal to the ratio or the slope of the smaller triangle And for its height, that is y3 divided by, so what is its horizontal distance? So that is just 6 meters. So this dimension here is just 6 meters. So solving for the value for y3. Y3 is now equal to, so 0.78, 781 times 6 divided by 18. So 0.781 times 6 divided by 18. Y3 is now equal to 0.26. Okay? So 0.26. So after knowing the value of y3, let me just erase that. So again, the value for y3, that is, 0.26. Okay, so for the bar force TJ, so for the bar force here, as brought about by the 40 kilonewton load, that is basically equal to, DJ is equal to 40 kilonewtons times y1 plus 50 kilonewtons, so this is now 50 kilonewtons, times y2 times this value, plus 50 kilonewtons times y3. Okay? So, if ever that those three are the only loads present in our truss member, just substitute all known values, press them in your calculators, then you already have the answer. However, guys, in this example, we have a uniformly distributed load here. So that is 15 kilonewton per meter. So just like in our previous lecture, what we did is that we are just to multiply 15 kilonewton per meter divided by the area that it is projecting. It is just that in this scenario here, guys, the value of the 15 kilonewton per meter load is projected or is projecting to the whole area of our graph. So meaning, guys, that this area of the uniformly distributed load would cause compressive stress onto our truss member, and this part of the uniformly distributed load would now cause tensile force onto our call this onto our bar force, which is bar force DJ. Okay, so by that, guys, again, that is plus, that should be 15 kilonewton per meter. So plus 15 kilonewton per meter. So plus 15 kilonewton per meter times the area of ILD under uniform load. Okay, so in here, what we would be doing here first, in order for us to get the area of the whole ILD, let us find this particular point here, whatever this dimension is. So why would we do that? In order for us to solve for the area here. So let us name this as area 1 and let us name this as area 2. So for area 1, as for the area of a triangle, that is basically 1/2 base times height. Whereas the height is this dimension here, and as for the base, that is this dimension here, from this point to this point. So same is true as with this. So area 2 is equal to 1/2 times base times height, whereas the base is equal to the whole dimension from this point to this point. And for h, that is basically y2 or 0.781. Okay, so in order for us to do that, let us remove first our solution earlier. So what we would be doing, guys, is okay, so what we would be doing here, guys, is for us to treat this slanted line here as the hypotenuse of a triangle. Okay, so again, earlier, this is just a line or a slanted line, but let us extend this and let us treat this the hypotenuse of a triangle. So if this is the hypotenuse of a triangle, we could say that this here is basically 6 meters. So that is given in the problem. And if this here, if this height here is 0.781 and this here is 0.52, we could now say that for the whole distance here, that is basically equal to 0.781 plus 0.52. Okay? So, again, guys, let us treat this as a triangle. And what we are solving for now is the value of x. Okay? So, in order for us to get what is the location of this point here. Okay? So, proceeding, guys. 0.781 plus 0.52. So, looking at the calculator. So, 0.781 plus 0.52. The answer there is 1.301. So, from that, guys, the answer here is 1.301. Okay? And again, this is 6 meters. So, from that, guys, how could we solve for the value of x? So, let us assume that there is a triangle here. Well, actually, there is, and that is now our point of analysis. So, from that, guys, so if we have a triangle here, this distance here is the same as with this distance here. And this is negative 0.52. And again, this is x as for this value here. So again, this is x. Okay, so in order for us to solve for the value of x, so let us get the ratio of the first or the bigger triangle first. So for the bigger triangle, that is, once again, 1.301 divided by 6. Okay, so vertical over horizontal. Okay, so let me just erase that first. Okay, so vertical over horizontal. This is now equal to vertical. So let us now consider this smaller triangle. So the vertical of this smaller triangle, that is 0.52. So 0.52 divided by x. So if this is x, this is the horizontal component. So from that, x is now equal to, solving for x, you could also use shift solve, but I want to do it algebraically. So 0.52 times 6 divided by 1.301. So the answer here is 2.398. Okay, so meaning that this distance here, so this distance here is 2.398. And from that, guys, this distance here, if the whole, if this whole distance is equal to 6 meters, so meaning that for this distance here, that is 6 minus 2.398. So that is 3.602. Okay, so for this area here, for area 1, so for area 1, that is equal to 1 half times base. So for the base, if this is 6 meters, 6 meters, so the answer here should be, or this length from this point to this point, so if this is 6, so 6 plus 6 plus 2.398. So 6 plus 6 plus 2.398. So this is 14.398. Okay. Times, so again, that is just the base. The height is negative 0.52. Okay. And from that, the value for A1, that is now equal to 1 half times 14.398 times negative 0.52. So the answer is negative 3.74348. Okay, and as for area 2, that is equal to 1 half times what is this whole length here. So we have 3 spans. So 1, 2, 3. So that is 3 times 6. So that is 18 plus 3.602. Plus 3.602. Okay. So answer, this now equal to 21.602 times the height. So again, the area of a triangle, that is basically 1/2 base times height, and the height is 0.781. So from that, the answer here is now equal to 1/2 times 21 points. Sorry. So again, 1/2 times 21.602 times 0.781. The answer here is 8.4356. Okay. So this is for area 1 and this is for area 2. So finally, let me just put the areas here. So for the area, this is negative 3.74348. And for the area here, this is, it's the other way around. So this must be positive 8.4356, and this is negative 3.74348. So erasing this, okay, so erasing this, the value for DJ is equal to 40 times negative 0.52. Apologies, this must be negative. So that must be negative since this is a negative value. Sorry, negative. Okay. Plus 50, and that is this value here, 50 times 0.781. So this is 0.781. So 50 times 0.781 plus 50 times 0.26. So this is what we have that we have solved earlier. So times 0.26. So that is the effect of these three forces. And as for the what you call this slide here, or this uniformly distributed load, so that is plus 15 kilonewton per meter times, so since the whole 15 kilonewton per meter is acting on the whole area 1, so times area 1, and that is negative 3.74348. Okay, plus, so we would now once again project this. So let us project this 15 kilonewton per meter load, and since it is projected also to the whole of area 1, then plus 15 times area 1 of 8.4356. Okay, so again, as for this equation here, 15 times negative 3, that is 15, the whole of this, times this whole area. And as for the other, that is 15, so this is still 15, times this whole area here. Okay, so from that, guys, you would now be having an answer of, so finally, so 40 times negative 0.52 plus 50 times 0.781 plus 50 times 0.26 plus 15 times negative 3.74348 plus 15 times 8.4356. So for a moment, times negative 0.52 plus 50 times 0.781 plus 50 times 0.26 plus 15 times negative 3.74348 plus 15 times 8.4356. The answer here is 101.6318 kilonewton. And since it is positive, it is experiencing a tensile force. So this is now our final answer. So there.